Thank you. There's 10 of us in Portugal, and we're all like this. Yeah, so so when I started doing this talk, I had very high hopes for my ability to do things, and I made a talk about building a Game Boy emulator in JavaScript. Because so me and my partner fixed Game Boys, and I really liked this era. So I was like, yeah, I can make a Game Boy emulator. I did not make a Game Boy emulator. Turns out, I'm gonna be honest, emulators are hard to do. I was not aware of. I mean, I was aware, but I was like, nah, I can do it. No. So now this talk is building an emulator in JavaScript. So as said, my name's Sara. I'm from Portugal. I live in London. I'm sorry if this is too loud. I'm trying to push it down. There we go. I live in London, and I hate the Berlin airport, and that's all you need to know about me. Cool. Okay, so this slide is what I'm going to show you right now in this talk is definitely legal. But I'm not a lawyer, right? There's two reasons I have this here. One of them is that I've always wanted to have something like this on a slide, on a talk that I did. I think it just looks cool. It makes you look badass, that you're like, yeah. The other one is that I think there's a lot of misconception about emulation in general. So who in here has emulated any sort of video game console or something like that? Okay, cool. Nerds going to jail. I'm actually a cop. Can you imagine? So there is a bit of a misconception. So it's I don't know the precedent for most countries. I only know the precedent for the US. I'm not American, but I feel like we all are in a very meaningful way, ever more. So back in the 2000s, this was, I think not the 2000s, but in the year 2000, there was a company called Bleem. An actual company got up one day and decided to call themselves Bleem, and I think that's beautiful. So basically this company made a PlayStation emulator. They wanted to make a PlayStation emulator, and they went to Sony, and they were like, we would like to emulate your console on Macs and computers. And Sony was like, what the fuck are you talking about? It's not gonna happen. We want people to buy the console. So they reverse engineered it and made an emulator that worked on MacBooks. So back in the day, you could actually play video games on a MacBook. This is not really a problem anymore, but I feel like it's still a good joke. Actually, 3 years ago, I played Final Fantasy VII, the original one, on my MacBook, emulating with DuckStation, and it was genuinely slow. So I feel like in 2000, you could probably play better PS1 games on your MacBook. I have a Steam Deck. So this company did all of this, and then they sold it as well. And you can actually see a video of Steve Jobs being like, you can run video games on a Mac. And it's such a weird time skip. And so Sony was like, bro, you can't do that. We're gonna sue you. And they did. And turns out since Bleem was not using any proprietary code, it was classified as reverse engineering, which is protected by law in a lot of countries. And Bleem won. So after that, it has been basically decided that as long as you're not using proprietary code, and that's why a lot of emulators ask for something called a BIOS, because that part is proprietary to the actual console, emulation is completely legal. But do not fuck with Nintendo, they will take you down. It doesn't matter if it's legal or not, they will take you down. They have more lawyers than your country has people. I'm not a lawyer. So again, I repeat, you do not want to become the 3DS emulator guy. Okay, so what is emulation in a more generic way? So basically emulation is when one thing pretends to be another. So let's say this computer pretends to be a PlayStation 1. So usually there are two different types of emulation. So So there is hardware and software emulation. So there is something called FPGA, which is the most known type of hardware emulation. So there is this handheld device called the Analog Pocket, and there's also a bunch of Game Boy card readers and stuff like that. So this is hardware emulation, which is emulated on the hardware level. So it's the chips and all of that, all of the fancy stuff that comes from PCBWay. That's all emulated to basically act like the hardware is a Game Boy. So it's not software. It's not you telling it when you get this instruction, do this. It's the hardware acts exactly like a Game Boy hardware would, right? Or any other sort of thing. I am so sorry. but I can hear myself breathing, and I am not having a great time with that. Okay, cool. Cool. So we're not going to be talking about hardware because I don't have that kind of skill set. I've ordered my first PCB, and it was supposed to arrive yesterday, but I'm clearly here, so I have not touched it with my hands. And I'm very sad about that. I have to ask DHL to keep it, and I don't trust DHL, or any shipping, doesn't matter. So we're going to be talking about software, right? So we're going to be talking about like, okay, can I pretend to be an emulator? How do I make it pretend to be an emulator? Okay, cool. Okay, so why the hell would you make an emulator in JavaScript? Honestly, you should not. Like, it's a terrible idea. It's mostly for people like me who are like, why not? I want to build something cursed, so I'm just going to make it in JavaScript because it's also the language I know the most. Like, I could have, like, is it a better idea to make it in Rust? Yes. Would it take me 3 years and probably 4 depressions? Yes. Yes, it would. And I know some Rust. So maybe 2 depressions. But like the thing is, like, I know JavaScript, and I was like, okay, like I can try to make this in JavaScript. But JavaScript is definitely one of the worst languages for this. Like, I'm sure there are worse languages, but JavaScript is not something that we're used to using in a low level, right? Emulation is very low level. It's not like, you know, the document and the DOM and everything. It's more like, you got this byte, and now do the thing with the byte and shift the byte to the right, and JavaScript is like, you're not supposed to do that. What the hell are you doing? This is what C was made to do. So yeah, would I recommend it? No. That's it. I would not recommend you to do it. Okay, so again, I started with the idea of making a Game Boy emulator, and then I've learned that I have the scant. I mean, I'm still going to try to make it, but the sound scares me. But what we're going to do is an emulator for something called the Chip 8, which I had never heard of. I don't know if anyone here has heard of this. No? Yeah? Okay, cool. At first, I thought it was Pico 8, which is another thing, and I was really excited, and then I found out it wasn't. But Chip 8 is mostly known for people who want to get started doing emulation because it's like baby's first emulator, right? So basically, all of the instructions that are sent are all on Wikipedia. Everything is open source. You don't have to like reverse engineer anything. Everything is already there, ready for you, and you can just pick it up and start doing in JavaScript, because that's a great idea. It's also like very simple, right? So in general, I mean, not all of them, but in general, all game consoles and just stuff in general has hardware. So whatever it is, may it be a microcontroller, for example, or maybe like a UJAS motherboard, a screen, a keyboard or a gamepad, and sound, right? One of the main reasons why I jumped to Chip 8 was because the sound doesn't actually modulate, right? It's just like, it either boops or it doesn't boop. It does not beep, it does not do anything else. It just boops. And I love that. So I don't have to like, JavaScript sound scares me, I don't know. And you have a keyboard, so in this case you do have a keyboard, but for example on a Game Boy you have a gamepad, on an NES you just have like 4 buttons, and you have a screen, and you have the actual components, right? You have the thing that makes the thing go, the microcontroller and the PCB. This talk is not sponsored by PCBWay. So the screen is quite simple on Chip 8. So it's like, it's 64 by 32 pixels, which to me is imperceptible. Like, I have really bad eyesight. Like, I am supposed to use glasses, but I don't know, I rebelled against my own glasses. Like, when I was a kid, I used to like walk around the house with like one eye in the middle. Like, I looked like I had been like cursed. And my mom took me to the witch, and the witch told her to go to the doctor. You should visit Portugal, it's a great country. The place where I'm from has 2 churches and 1 ATM. Why do you need money when you have Jesus? And it's monochrome. Sorry about that, sorry. And it's monochrome, so it's like, it's either white or black. I mean, it can be green and yellow, like you do whatever you want. I'm not doing that. I'm not gonna make it look like barf, but you can. So it's either black or white, which is great, because that helps us try to create something. Because you, technically, like when I started like this journey, my thought was like, okay, let's say you want to make a Game Boy emulator. Let's say you want to make Super Mario Land, right? I thought I had to draw the actual pixels on the screen. Like you had a canvas and you had to draw all of these pixels on the screen. Turns out that's not how it works at all. I was just an idiot. I never grew out of that phase. But basically how it works is that there's sprites, right? And there's these sprites that are usually either 8 by 8 or 16 by 16. No, not, or 16 by 8. And then you just have to like, what it tells you is go to this, get the sprite, put it on the screen. And I was like, oh, I don't have to draw it. Like, I don't have to use the Canvas API. That's beautiful. I don't want to have to use the Canvas API. So you don't. It's great. So, but in this case, it's even easier, because first of all, we don't really have a lot of pixels, right? We can just make an array of all these pixels. Like, just make an array, and the array is either 0 or 1. When it's 1, it's filled in. When it's 0, it's not filled in. So, guess what we're going to do? No, seriously, guess. We're going to make an array. So the display is an array of 32 by 64, and we're going to fill it with 0. And basically, in this case, 0 means there is nothing in it. We have not filled this in. We will in the future if it works. Also, again, 64 by 32, completely imperceptible to the human eye, I feel like, at this point. So I'm adding a scale. I'm also passing a canvas. So basically, this was made in a way where like you can install it and use it at NPM. So you pass the canvas and you pass the scale yourself. And you have colors. So if you want to make it look, I don't know, like a spaceship, you can. But basically, it only has black and white. So I just chose black and white. So then you end up with the width of the canvas and the height of the canvas. And you multiply this by the scale. So let's say that your scale is 2. So you want to multiply that by 2. And then you end up with... I'm not even fucking with you right now. Just genuine... Wait. That's just funny at this point. 128. Like, I think I could have got, like, I definitely could have gotten that by myself, but I was like, you know what? No, I'm taking this bit to the end. So you end up with 128 by 64. See, I did the other one by myself. I failed math in high school. Twice. On the same year. And then I changed schools. I never finished math. No, I did. Okay, cool. So the CPU itself is pretty simple as well. So you have 4,096 memory locations of 8 bits each. Okay. Do any of you know? No, this is kind of like, even if you do know, you're not going to be yelling it. That's just absurd. Okay, so there's, back in the day, there was a bunch of like fight over the number of bits your console had. So for example, an NES, a Nintendo Entertainment System, had 8 bits, right? Did you have Mega Drives here? Because that was the most common thing in Portugal. Like everyone had a Mega Drive. I don't know why. And the Mega Drive, for example, was 16-bit. So what the fuck was the difference? And did it actually matter? Yes and no. So basically, 8-bit means your computer, whatever it is, in the case of the NES, was a... Why did I say it was a when I didn't remember the name of the microcontroller? It was a controller. It was a chip made by the company that got bought by Commodore. I watched a video on this yesterday on YouTube. So an 8-bit allowed for numbers up 256 numbers, so 0 to 255. So like if it ever happened to you when you were playing an older video game where like it went to 255 and then it went back to 0, that's why. It's because it literally could not do it. So this is what 8-bit means. So when you were at 16-bit, it means you could do way more computation because you're not like limited by that anymore. So it did matter, but like a lot of stuff, so let's say there was a console at the time that was the TurboGrafx 16. It came out in Japan. I think it also came out in Europe, but no one bought it because it was expensive. And the 19s in Europe were not a great time. The 2000s were great though. And this wasn't really a 16-bit. It was more like it had 2 8-bit processors in it. So it was like, a lot of it was a fucking lie. And it also had 16 8-bit data registers. So data registers, you can think of it like you can actually save data in it, so you can use it to get a high score, for example. You can use it for all sorts of different things, but you can actually save data and get data. That's really important if you're trying to make like a video game or, you know, a software. I don't know why you would make a software. I mean, I guess there's things like, someone made like an operating system for the NES. Not me. No, I don't have that kind of, but yes. So this is the game that we're trying to emulate. So it's a clone of Breakout that's CC0. You can find it on GitHub. So a lot of most of the games for the Z80 are written in assembly. So Z80 assembly, which was the same thing that was used to make games for the NES, and I think for the Game Boy as well. People used to hand code assembly, and I think that's just wild. I mean, I think it's beautiful in a fucked up way. I wish that was me. But this is the game, right? And I thought, like, okay, I'm gonna get this ROM, and I'm gonna read the context, and the, not context, the contents of it, and it's just gonna be like, you know, assembly, and I'm gonna to basically create an assembly parser. Like, that makes sense, but that would be too easy. And that's not what we're here for. So if I load it, what I see is this, which is an 8-bit array of just numbers. And I looked at this at the first time, and I was like, I don't think TypeScript can help me anymore. I don't think anyone can help me anymore. I think maybe Jesus can help me. But like, that sounds like a whole like experience that I'm gonna have to have that I don't wanna have right now. But what the fuck, right? So you basically have to go through here and be like, okay, this is an array of 8-bit, and I have to go through each of them and see what it's telling the computer to do. And do you know how you do that? With a big old switch statement that I'm gonna show you in a bit. But there's also another thing that's really important, and I know this is a bit of like a step to the side, but I wanna talk about both hexadecimal notation and bitwise operators. Okay, so hexadecimal notation is what has been used in a lot of like these older systems. It's still used today, but instead of being base 10, like we have, so we have 0 to 9, it's base 16, and it basically goes from 0 to F. So if you see an F, it just means 15. So you have to like do this math, but that's the basic what the fuck? Gist of it. Thank you. Yeah. So that's the main thing. And like, I was struggling for the longest time to think of a way to talk about hexadecimal notation. And then my partner was like, what about hex colors? And I'm like, oh dear, that's such a good idea. Because like, she can do this thing where like, you give her a hex color, and she can see the color in her brain, like in the Matrix. And I think that's just mind-blowing. Like, you yell a color at her, and she'll be like, yeah, that makes sense. That's purple. We also get like, so there's this restaurant chain in the UK called Nando's, and when you order through the app, they give you an order number that's just a hex color, and 95% of the time she can guess what color that is, and I think that's just incredible. So, hex colors. So let's look at this color. I also used to use white for this example, and then she was like, why? So we're gonna use the color badass, right? So this is hexadecimal, and we can look at it and be like, okay, so if F is 15, we can see that B is 11. Right, and A is 10, and blah, blah, blah. But we need to make all of this math, right? We need to understand, like, how does this work? Okay, so let's divide it into the bytes, and every byte has, in this case, 2 nibbles. There's other names for it, but I really like the name nibble. So the B, for example, is a nibble, the A, the D, the E. So we divide it into bytes, and the first byte is BA. And basically, again, to transform it into into decimal notation, we basically have to we have to transform it into decimal notation. And how do you do that? You basically know that instead of being at a base 10, it's at a base 16, and you have a B, and you have an A, and starting from the A, you basically go, okay, that's 10 times 16. Because A is 10, and you just time it times 16, and then you add the power of 1, so like it continues like this, and you're like, okay, it's 11 times 16 to the power of 1. Like this, honestly, you can just use an online like thing that does this for you until it makes sense. But yeah, so then you go, okay, that's 11 times 16 plus 10 times 1, that's 186, and then you just do the same thing with DA, which ends up being 13 plus 10, and that ends to 218, and then you get 5, which is the easiest one, right? It's just the same thing, because 5 is always 5. The only constant in life is 5. And that's 85, which also has a 5, and that ends you with this, which is 186 to 218.85. Does that look like something, if you think about colors? That's RGB. And it blew my fucking mind. So that's badass in RGB, and I can prove that if you don't believe me, because I didn't believe me. But if I go here, and I change this, there we go. It's the same thing. Blew my mind. I'm still mind blown about this. Cool. So what are bitwise operators? They are the pain that will grow inside of you. So let's say you have 2 bytes, and let's think about a way that this is structured. So a 1 is a positive, a 0 is a negative, right? You're just talking in binary at this point. This 0x basically tells the browser this is a number. This is what you have to use in JavaScript to basically tell it this is binary, or this is what this, like this is hex, right? So you have 11 and 10, and what does this mean? This is an AND, so it basically means only if the 2 nibbles are positive will the next one be positive. So these are just bitwise operations that are heavily used in like emulation, basically. So in this case, the first one, so 0 and 1 is not both positive, so it ends up with 0, and then 1 and 1 both positive, so this operation, let's call it that, just ends up with 10. Does that make sense? Really? Okay. Cool. So that's an OR, and it basically stands, it's the same, but the exact opposite. So, I mean, it's an OR. So if one is positive or the other one is positive, it's positive. And that's an XOR. Yeah, that's a NOR. That's a NOR. So you basically just remove one. Like, yeah. If both are positive, it gets removed. Okay. So then we get a bunch of instructions, and they are all in hexadecimal byte stuff, and you have to like shift the bits and the bytes and the nibbles. And what do you do with it? Now we have to tell the computer what to do with a big old switch statement. Okay, so you get an opcode, and that is the instruction that you get, and then you get that N. And basically what that N means is like ignore everything that's the 0. So we're ignoring every other nibble, and we're just getting that one that's the F, right? Does that make sense? Okay, cool. There's only one person that said yes. I just realized. Does that make like 45% of sense? Because that's how much it makes to me, so that's fine. Cool. I think I only heard another one, but that's fine. We're going to continue. So let's say that you get this hex code, 42F3, and if you do an AND with that, it basically, you just end up with a 4. Because everything else has to be ended, and you're never going to return anything if you just ended with zeros, right? So let's say that you get this, you get a 0 out of it, so let's say you get like 0, 1, F3, then in that case, with that end, you would just still get a 0, and then you just switch on that opcode. And basically, all of these hexadecimal values are on Wikipedia, like they are also on the guy's website, and you basically go through them and be like, okay, what does the computer want me to do? So basically, in this case, it wants you to clear the screen, and in another case, it wants you to pause the action, right? Or render in a specific location. So you basically have to go through all of these and be like, okay, what does it want me to do? And how do I do it? So you can imagine how fucking insane this gets if you're doing like a PS4 emulator, right? Like, yeah. Okay, so now do you want to see all of the switch code? And this is for like a very small emulator, right? Like, again, like if you're gonna make something huge, it's gonna get insane. Like, it's gonna get insane. So, yeah, that's the idea of how to make an emulator. I hope this made sense and that it can get you on the right track into trying to get started with this kind of stuff. Like, it's intimidating, but it's also like very rewarding to use JavaScript for these kinds of things that you think you can really only use, like, you know, C or something. So it's nice. So now I'm going to show you the emulator, which is basically just this. So it plays Breakout, and I can move the paddle to the other side, Sarah, to the other side. And there we go. You can also update like how fast it's going. I put it to be slow because I'm really bad at this. But yeah, that's the idea, and that's what I made. And you can install it if you want. I don't know why you would, but you can. And that's the most important part. So yeah, if you want to see my slides, you can scan the first QR code, and that's my blue sky. And yeah, thank you so much for having me. Have a great day. And that's it. I got nothing else. Thank you.